So in this video, we're going to look at an application problem that uses the mean value theorem. So this problem says the height of an object, t seconds after it is dropped from a height of 300 meters, is modeled by height as a function of time, equals negative 4.9 t squared plus 300. So the height model that we've been using since pre-calculus. It says find the average velocity. So it's going to be broken into three pieces. Find the average velocity of the object during the first 3 seconds. Use the mean value theorem to verify that at some time during the first 3 seconds the instantaneous velocity equals the average velocity. Find that time. So there's 3 things to do. Find the average velocity, verify the mean value theorem can be used, and then find the associated time that the mean value theorem guarantees exist. So first thing to recognize is that if you're working over the first 3 seconds, you're really letting time run over the closed interval from 0 to 3. So if we're calculating the average velocity of the object during the first 3 seconds, we want to find the average velocity over this closed time interval. And the average velocity is just going to be the height at 3 seconds minus the height at 0 seconds. We evaluate the height at the interval endpoints and take that difference. So we get change in height divided by 3 minus 0, the change in time. Change in height is in meters. Change in time is in seconds. So we have meters per second, which is our velocity. So there's our average velocity. So to get the average velocity, we just plug the 3 and the 0 into the height function. So we get negative 4.9 times time squared plus 300, plugging the 3 into the height function, minus parentheses, now plug the 0 into the height function. So we get negative 4.9, 0 squared plus 300, and this is all over the change in time. Change in height divided by change in time. 3 minus 0 is 3. Negative 4.9 times 3 squared, so it's negative 4.9 times 9 plus 300 minus negative 4.9 times 0 is just 0, so it's minus 0. Minus and plus makes minus 300 all over the change in time. 300 minus 0 minus 300 is just 0, so we get negative 4.9 times 9 over 3. And 3 goes into 9 3 times, so we get negative 4.9 times 3. So 3 times the 9 is a 27. Carry the 2, we get 3 times 4 is 12, plus 2 is 14. There's our decimal point from right here. And we need the negative on it. So the average velocity is negative. It's because the object is going down towards the Earth. So down has been defined with the height model as being negative. And this is a velocity, so it's measured in meters. We're measuring in meters, and our time units are in seconds. So it's meters per second. So this is the average velocity of the object. So that's step 1. Find the average. We've done that. Step 2 is to verify using the mean value theorem that there is a time during the first 3 seconds for which the instantaneous velocity matches this average velocity calculation right here. So remember, the mean value theorem has 2 criteria that you have to meet. Your function has to be continuous over your closed interval, and your derivative of the function has to exist over the open interval in which you are interested. So what we want to recognize is to establish that h is continuous and h prime exists, we want to recognize, like we've done in previous videos, that this is a polynomial. I want to say, hey, this is the verify step, kind of a part B. We did part A, which was to find the average. We want to say, hey, the height function and the derivative function, when we take the derivative, they're both polynomials. They are both polynomials. we know that polynomials have domain negative infinity to infinity. You can put any real number you want into a polynomial. Nothing bad happens. You don't get a division by 0. You don't get the square root of a negative number. Everything is copacetic. So if the polynomials both have domain from negative infinity to infinity, then clearly h will be continuous from 0 to 3, which is a subset of negative infinity to infinity. And the derivative will exist on the open interval from 0 to 3, which is clearly a subset of the open interval from negative infinity to infinity. So clearly, then, h of t is continuous on the closed interval from 0 to 3, and that's because it's a subset of the domain of h of t, and h prime of t exists on the open interval from 0 to 3, which is clearly a subset of the domain negative infinity to infinity of the polynomial that's going to be the derivative of h. So because we've met both criteria for the mean value theorem, we can conclude that the mean value theorem guarantees the instantaneous velocity will match the average velocity for some time on that interval from 0 to 3. Therefore, by the mean value theorem, there must exist a time t on the interval from 0 to 3 at which the instantaneous and average velocities are the same. So that's the verify step. So part B. So on a homework or exam, if it says to verify that you can use the theorem and you don't do this because you don't feel like writing, it means that you don't get credit. You lose all of the points for the verify step. So this is a 3-point problem. You just lost a third of the points. You can get at best a D on the problem by skipping the verify step. So once we verified that the time exists, that there is a time on the interval from 0 to 3 at which the instantaneous velocity matches the average, now we just need to find that time. And what we want to recognize is that here's our height function. Our height is negative 4.9 t squared plus 300. The derivative tells us the instantaneous rate of change of the function h. So the derivative h prime is going to be, bring the 2 down, we're going to get negative 9.8 times time plus the derivative of 300 is 0. This is the derivative, or instantaneous rate of change. So the mean value theorem guarantees that there is a time on the interval from 0 to 3 at which the derivative, or instantaneous rate of change, will match the average. So we need to set the derivative equal to the average. But the derivative is just negative 9.8 times time. So when is the derivative equal to the average? Or when is the instantaneous rate of change equal to the average rate of change? Divide both sides by the negative 9.8 to get time by itself. And negative 14.7 divided by negative 9.8 is 1.5 seconds. And notice that 1.5 seconds is in the time interval from 0 to 3. The mean value theorem guarantees there will be a time. So we know that h prime of 1.5 equals the average. The instantaneous speed at 1.5 seconds equals the average speed over the entire time interval from 0 to 3.